All right, continuing on, we're going to look at more alkyl groups and looking at some more complicated substituents. Okay, so remembering, right, alkyl groups, right, so not alkanes, but groups attached to alkanes, are replaced by the ane suffix with the of the parent name, and they're replaced with YL, right? So, of course, we have our methyl group, ethyl group, propyl group, butyl group, and so on. But, right, things can get branched. Especially after the second carbon, we can now, instead of having things in a straight chain, things can be even further branched. So there's a complicated way to name these more complex substituents, but these are some of the commonly utilized names for some of them. So when we have three carbons kind of branch off like this, right, with two, looks like methyl groups coming off of the central carbon here, this is isopropyl. And likewise, when we have four carbons with the first carbon here branch, that's sec-butyl. This one is tert-butyl, right, with three carbons coming off of that carbon here. And then finally, we have isobutyl when we have four carbons with the methyl group in that middle one. Okay, there's a different way to name these, but these are the common names for these four particular substituents. Okay, and this will make sense a little bit later when we go into naming them, right, in a slightly different way. And also, apart from just naming carbons, we can also name halogens, right? There's nothing really particularly fancy here, but they're treated, right? Halogens are treated similar to alkyl groups when naming, right? But instead of worrying about the number of carbons, we just have to worry about what halogen is, right? So we just have fluorine, chlorine, bromine, and iodine, right, as shown out here, right? So in this carbon chain, we have 2-bromobutane, right, seeds in that 2 position. And this one, right, we have 3-chloro-2-methylpentane, okay? And then finally, we have 4-fluoro-2-iodohexane, okay? So go through these and try to convince yourself that these all sort of make sense, okay? Maybe even get rid of the name and see if you can name them on your own, remembering the rules that it gave you, okay? So, right, complex substituents, right? These four are the ones I just told you about, right, with the isopropyl, sec-butyl, and so on. But when substituents are attached to an alkyl chain, attached to a parent chain and named by systemic method using the longest alkyl chain as the base alkyl chain, we can further kind of go into that, right? So instead of just saying, oh, like we have a such and such group, we can actually name the group even further, okay? And the way we do this, right, is the base alkyl group is numbered beginning with the carbon atom bonded to the main chain. And then the base substituents on the base alkyl group are listed with the appropriate numbers, and the parentheses are used to set off the name of the complex alkyl group. So, in short, what that means is we're kind of treating it like the similar naming process, but instead of just using alkane as the root, we're now sort of using the alkyl group as the root. All right. So what that means is, looking at this first example, right, pretending we don't know what the name is, we would say, okay, this is carbon 1, this is carbon 2, right? Of course, we have this one carbon up here. So we would say, okay, 2, we know that is F-O, and attached to the one carbon, we have methyl, right? And we could do that for all of these, right? Going through to the second one, we say 1, 2, 3, right? We know that is propyl. Attached to the one carbon is that one methyl, right? And so on and so on. Going to this last one here, which is a little bit more complicated, there's more substituents, right? We can go through and name this as well. We can say 1, 2, 3, 4, right? But what we can't do, right, because it might be tempting to start numbering from this top one and go 1, 2, 3, 4, 5, 6, right? Because that would be longer. However, it doesn't really work that way with the substituents here, right? Because remember, this entire thing is a substituent, right? It's attached to another molecule. So we have to number it from the largest chain, the longest parent chain, which gives us the most substituents, right? So we know that this is butyl. We know attached to the 1 position is ethyl. And attached to the 2 and 3 positions is dimethyl, right? And we use di here because there are 2 methyl groups, but they're on different carbons, right? We wouldn't say 2-methyl dash 3-methyl. We would shorten it like this, right? So 2, 3 dash dimethyl. And stringing it together, we get this. So furthermore, we can also look at cycloalkanes, right? And the only difference here is instead of saying something is, for example, propane, when it's in a ring, right, then it is instead just cyclo, right? We just add cyclo to the beginning of the root, all right? So looking to these different names, right? So again, prefix cyclo attached to the root. Root is the number, again, carbons in the ring. No number is needed if only one group is attached, right? Like with this example here, right? We wouldn't say this is one ethyl cyclopentane. There'd be nothing wrong with that, but because there's no other substituents to differentiate it, right? This ethyl group could be anywhere on this ring, and it would be the same molecule, right? So we just say this is ethyl cyclopentane. So if there are multiple substituents, start with one and go in the direction that leads to the lowest numbering, right? So looking at the example down here, right, the name's already given to us, but if we weren't sure how to name it, right, we would say, okay, which direction do we start from, right? We would start from the left, right, because it gets us the lowest numbering right off. See 2,4, right, 2-methyl-4-cyclopropyl. If we numbered it the other way, 1, 2, 3, 4, 5, 6, right? 3 and 5 would be our substituents rather than 2 and 4, so that's an overall bigger number. Importantly, if the ring is smaller than the number of carbons on the longest chain, then it becomes the substituent, right? Because cyclopropyl only has 3 carbons, and that is smaller than the overall parent chain, the overall root, which is hexane. All right. And looking at this one here, right, similar to a previous example we showed, we want ethyl to be in the 1 position and methyl to be in the 3 because ethyl is a lower, it's higher in the alphabet than methyl, right? It's closer to A. So we would want 1 to be closer to the alphabetically first alkyl group, okay? And so when we do that, we name it like this, right? 1, 2, 3. But if we were to name it the other way or try going a different way, 1, 2, 3, 4, that wouldn't be correct, right? Because then it would be 1 ethyl, 4 methyl, and we can number it lower by going the other way around the ring. And I would encourage you, right, to kind of not look at the names here and see if you can name them on your own now that we've gone through some of them. All right, so we will go through this example together in class, but I would encourage you to try it on your own. Naming things can be a little bit tricky and tedious, so definitely practice is going to be key here, and this is the best way to do it, especially going through the problems I already gave you here, the examples I already gave you, and see if you can name them on your own, right, and then look at the answer again.